Hello everyone and welcome to the lesson Kcse 2018 paper 1 question number 19. The question is on kinematics. So let's go direct to the question. So the question reads, the distance covered by a moving particle through O is given by the equation S is equals to t cubed minus 15t squared plus 63t minus 10. Find the first question. A, the distance covered when t is equals to 2 max. B, the distance covered during the third second, that is 3 max. Then the third question, the time when the particle is momentarily at rest, that is 3 max. Then you have the last question, which is the acceleration when t is equals to 5 seconds. So those are the questions. We want to begin with the first one, that is the distance covered when t is equals to 2 seconds. So the distance is denoted by s, and to get distance when t is equals to 2, we simply take the expression for the distance and replace t with 2 seconds. That is what you're supposed to do. So 2 cubed minus 15, 2 squared plus 63 to brackets 2, then subtract 10. When you do this calculation, you get this 8, this is minus 60 plus 126 minus 10. Now working this one using a calculator, you're supposed to get 64 meters. So that is the distance covered when t is equals to 2. Now let's go to the distance covered during the third second. The distance covered during the third second. Now it is important to note that during the third second, that means from the second between, you can just write it between second, that is okay, and the third. That is what we mean by during the third second. Is between 2 and 3 seconds. So we need to get the distances for both. When t is equals to 3, we get the distance for that. Then you get the distance when t is equals to 2, and we get the difference of the distances. So we start with when t is equals to 3, when time is equals to 3, I mean. So this will give s is equals to 3 cubed. We just replace t with 3 in that expression for the distance. 3 cubed minus 15, 3 squared plus 63 into brackets 2 minus 10. And this gives 27 minus this 15 multiplied by 9, which will give 15 divided by 9 is 5. 195 plus 126, subtract 10. Now working out this using a calculator, we get the distance when t is equals to 3 as 71 meters. So that is what you get. Now then we get the distance when the time in seconds is 2. We already got this, so we just need to get the distance. Previously we got the distance, so we got that. Therefore this one is 64. It is 64. When t is equals to, we had obtained that. So now that we have the two distances between, that is for t is equals to 3, 71 meters, and t is equals to 2 is 64 meters. To get the distance now, the distance between or during, I think it's good to use the right word that is used in the question. So distance during the third second, which you have identified to be the distance between 2 to 3 seconds, will be 71 meters. That is for the 3 seconds. Subtract 64 meters and you get 7 meters. So that is what you get. The next thing is the time when the particle is momentarily at rest. That is the third part of the question. The time when the particle is momentarily at rest. Now at rest, velocity is equals to 0. The particle is not moving, and therefore the speed at that instant is 0. So we need to get the expression for velocity. To do that, we shall differentiate SVA, when you're moving down, we differentiate. So we shall write this expression for displacement, and then when you differentiate that, that is when you obtain velocity. So let's get velocity by differentiating that. We get 3t squared minus 30t plus 63. So that is the expression for velocity. Now what we need to get now is what will be the time when velocity is 0. So when we replace that v in that expression for velocity with 0, we simplify, we get a quadratic equation. We simplify by dividing all through by 3, and this will give t squared minus 10t plus 21. Now this is a quadratic equation. You can use any suitable method, either the factorization method. You can use factorization. You can use factorization method, or you can simply use the quadratic formula, which is the best, that is easy for you, the one that you understand better, the one that is easier to work with. So let me use the quadratic formula. So t will be given by negative b will be positive 10 plus or minus b squared would be 100 minus 4 multiplied by 8 by c, which would be 84, divided by 2 times a, which is 2, a is 1. Now we work out this. T is equals to 10 is plus or minus 14. This is 14. Let me see something here to confirm. As that is 4. It is not 14, it is 4. So you get 10 plus or minus 4 divided by 2. So the first value of t will be given by, this will be 10 plus 4, which will be 14 divided by 2, and that one gives 7 seconds. Then the second value of t will be given by 6, 10 minus 4 divided by 2, which is 3 seconds. So we therefore have two instances when the particle is at rest. That is when t is equals to 7 seconds and when t is equals to 3 seconds. So those are the two instances or times. Now after obtaining that, I've answered that question. Now we need to get the acceleration when t is equals to 5, acceleration when t is equals to 5. Now that we've got the expression for velocity, we need to differentiate velocity. When you differentiate velocity, we get acceleration. So we'll take that expression for velocity, which is given up there. And this is v is equals to 3t squared minus 30t plus 63. Then you differentiate that to get acceleration. You get 6t, this 6t minus 30, and then you substitute when t is equals to 5. Just replace t with 5, and this will give 6 multiplied by 5. Then subtract 30. Of course, this will give 0. To give 30, subtract 30, which will be 0 meters per second squared. And that is simply how you're supposed to solve that question on kinematics.